Good afternoon, students. In the last class, we discussed about the inertia and types of inertia. Along with that, we discussed few concepts on first law of motion. Right. So today, before going to study or discuss the Newton's second law of motion, so one more parameter, that is linear momentum, or simply we call this one as momentum, right? So first we will know about the momentum, then we will discuss the Newton's second law of motion, right? So what is momentum or linear momentum? So it is the quantity it is defined or it is a quantity constrained during motion. So how much quantity is required for the motion of any object? So that one is defining by the term, that one is the momentum. Recall that one has also the linear momentum, or the quantity of the motion constrained during its journey or during its change its state of rest to or change of its motion, right? So that one we call as momentum or linear momentum, right? So for that, consider two objects, right? So one object calling A, and this object is heavier. Heavier means its mass is larger. So larger mass, we call that one as heavier object. So and consider one more object B, which is lighter one. So that means the mass is less as compared to that of the heavier. So here M1 and M2 indicates there is a difference in masses between the two bodies, that is one and that is A and B, right? So in this case, mass of the object A is greater than mass of the object B. So here M1 and M2 indicates the masses of the object A and M2 is the masses of the object B, right? So first, in the first case, these two objects which are moving with the same velocity, right? So same velocity, that's why we taken V, right? So that means both are moving with the same velocity. So heavier object is moving with some velocity. For example, it is moving with 10 meter per second. So same lighter object is also moving with 10 meter per second, but the masses are different, right? So here the force which is required to stop the heavier mass is more, right? To stop the object which having the heavier mass, right? So here we need to apply the force. So that force is the retarding force or opposition force, right? So ಯಾವುದೋ ಒಂದು ಆಬ್ಜೆಕ್ಟ್ ಹೋಗ್ತಾ ಇದೆ with some velocity, right? So either heavier object or lighter object. So heavier object requires more force to stop the object. So move ಆಗ್ತಾ ಇರೋ object ನ stop ಮಾಡಬೇಕು ಅಂದ್ರೆ force required more, right? For example, if the lorry is so heavier mass ಗೆ example, if we taken lorry and lighter mass car, so both are moving with the same velocity, right? So the force required to stop the lorry is more than the force required to stop the car, or the force which we are applied on the lorry to move its state of rest to motion. That means the force which we are applying on the lorry is more to change its state of rest than compared to the car. So now ಲಾರಿನ ಮೂವ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ ಹೆವಿಯರ್ ಫೋರ್ಸ್ ನ ಅಪ್ಲೈ ಮಾಡಬೇಕು, ಕಾರ್ ನ ಮೂವ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ ಲೈಟರ್ ಫೋರ್ಸ್, ಬಿಕಾಸ್ ಲಾರಿ ಹ್ಯಾಸ್ ಹೆವಿಯರ್ ಮಾಸ್ ಕಂಪೇರ್ಡ್ ಟು ದಟ್ ಆಫ್ ದಿ ಕಾರ್. ಸೊ ಇನ್ ದ ಸೇಮ್ ವೈಸ್, ಟು ಸ್ಟಾಪ್ ದ car lorry we need force, that one is the opposition force, right? So that opposition force is more, right? The force required to stop the heavier mass is more than the force required to stop lighter mass. So from this we can conclude, So heavier mass is required to stop, sorry, heavier force is required to stop the heavier mass, and lighter force is required to stop the lighter objects. That means the object which having the lighter mass, when these two are moving with the same velocity, right? So from this we can define linear momentum, or simply we say that one as momentum is directly relates with the mass, right? So here both are moving with the same velocity, so linear momentum is directly relates with the mass. That means force required for the heavier force is required for the heavier masses, and lighter force is required for the lighter masses. In both the cases the force is depends on the mass, right? So same as the linear momentum is directly proportional to the mass, so ಈ symbol ನಮಗೆ directly relates. ಸೊ ಮಾಸ್ ಜಾಸ್ತಿ ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ ಲೀನಿಯರ್ ಮೊಮೆಂಟಮ್ ಏನಾಗುತ್ತೆ, ನಮಗೆ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಮಾಸ್ ಕಡಿಮೆ ಇತ್ತು ಅಂದ್ರೆ ಲೀನಿಯರ್ ಮೊಮೆಂಟಮ್ ಏನಾಗುತ್ತೆ, ಕಮ್ಮಿ ಆಗುತ್ತೆ. ಸೊ ಫಾರ್ ಹೆವಿಯರ್ ಮಾಸ್ ದ ಫೋರ್ಸ್ ಅಪ್ಲೈಡ್ ಟು ಚೇಂಜ್ ಇಟ್ ಸ್ಟೇಟ್ ಈಸ್ ಮೋರ್. ಸೊ ಹೆವಿಯರ್ ಮಾಸ್ ಗೆ ಜಾಸ್ತಿ ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡಬೇಕು, ಲೈಟರ್ ಮಾಸ್ ಗೆ ಕಡಿಮೆ ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡಬೇಕು. ಸೊ ಸೇಮ್ ವೈಸ್ ಮೂವ್ ಆಗಬೇಕು ಅಂದ್ರೆ ನಾವು ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡಬೇಕು, ಅಥವಾ ಸ್ಟಾಪ್ ಆಗಬೇಕು ಅಂದ್ರೆ ಕೂಡ ನಾವು ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡಬೇಕು. ಮೂವ್ ಆಗಬೇಕು ಅಂದ್ರೆ ಇನ್ ದ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡ್ತೀವಿ, ಸ್ಟಾಪ್ ಆಗಬೇಕು ಅಂದ್ರೆ ಆಪೋಸಿಟ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ನಾವೇನ್ ಮಾಡ್ತೀವಿ, ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡ್ತೀವಿ. ಎರಡು ಕೇಸಸ್ ಅಲ್ಲೂ ಕೂಡ ಅಪ್ಲೈ ಮಾಡ್ತಾ ಇರೋದೇನು ನಾವು ಫೋರ್ಸ್, ಬಟ್ ಆಪೋಸಿಟ್ ಮೀನ್ಸ್ ರಿಟಾರ್ಡಿಂಗ್ ಫೋರ್ಸ್. ಸೊ ಆಪೋಸಿಷನ್ ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡ್ತಾ ಇದೀವಿ ಅಂದ್ರೆ ಹೆವಿಯರ್ ಆಬ್ಜೆಕ್ಟ್ಸ್ ಗೆ ಹೆವಿಯರ್ ಫೋರ್ಸ್ ನ ಅಪ್ಲೈ ಮಾಡ್ತೀವಿ, ಲೈಟರ್ ಆಬ್ಜೆಕ್ಟ್ಸ್ ಗೆ ಲೈಟರ್ ಫೋರ್ಸ್, ರೈಟ್? ಸೊ ದೇರ್ ಇಸ್ ಅ ಡಿಫರೆನ್ಸ್ ಇನ್ ಫೋರ್ಸ್, ರೈಟ್? ಸೊ ನಾವು ಲಾರಿನ ಪುಷ್ ಮಾಡೋದಕ್ಕೆ ಎಷ್ಟು ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡ್ತೀವೋ ಅಷ್ಟೇ ಕಾರ್ ಗೆ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ, ಕಾರ್ ವಿಲ್ ಮೂವ್ ಫಾಸ್ಟರ್ ದನ್ ಲಾರಿ. ಸೊ ಹಿಯರ್ we taken the cases both are moving with the same velocity, right? So same velocity ಅಲ್ಲಿ ಮೂವ್ ಆಗ್ತಿದೆ ಅಂದ್ರೆ ಇಲ್ಲಿ ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡ್ತಿರೋದು ಕೂಡ ಏನಾಗುತ್ತೆ, ನಮಗೆ ವೇರಿ ಆಗುತ್ತೆ, right? So this is in the first case there is a difference in masses, right? So in second case consider, right? So in second case considering again same two objects, object A having mass m and again object B having mass m. That means both objects having the same mass, right? But these two are traveling with different velocities, right? So for that here we taken v1 v2. So v1 v2 indicates there is a change in velocity. Here v1 is greater than v2, that means A is moving faster than B, right? So greater means larger value, velocity ಜಾಸ್ತಿ ಇದೆ ಯಾವುದರಲ್ಲಿ, A object ಅಲ್ಲಿ, velocity ಕಡಿಮೆ ಇದೆ ಯಾವ object ಅಲ್ಲಿ, B object ಅಲ್ಲಿ, but masses is same for both the objects. That means here in this case either we can take car as an example. So ಎರಡು ಕೇಸಸ್ ಅಲ್ಲೂ ಕಾರ್ ಏನಿದೆ ಸೇಮ್ ಇದೆ. ಸೊ ಕಾರ್ ಸೇಮ್ ಇದೆ ಅಂದ್ರೆ ಮಾಸ್ ಏನಿರುತ್ತೆ, ಸೇಮ್ ಇರುತ್ತೆ, ಬಟ್ ಮೂವ್ ಆಗ್ತಿರೋ ವೆಲಾಸಿಟಿ ಏನಿರುತ್ತೆ ನಮಗೆ ಡಿಫರೆಂಟ್. ಸೊ ಕಾರ್ A is moving faster than car B, or any object moving faster than other object, that is similar object, right? So in this case also to stop the object, so fast moving object na stop ಮಾಡಬೇಕು ಅಂದ್ರೆ we require larger force, right? So larger force is required to stop fast moving mass or object. So ಇದರಿಂದ ಏನು ಹೇಳ್ಬೋದು, ಆಬ್ಜೆಕ್ಟ್ ಫಾಸ್ಟ್ ಆಗಿ ಮೂವ್ ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ we need to apply larger force, right? So object slow ಮೂವ್ ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ we need to apply lesser force, right? So larger force is required to stop the fast moving mass compared to that slow moving mass or object. So slow moving means having less velocity, right? So ಎರಡು ಕೇಸಸ್ ಅಲ್ಲೂ ಲೀನಿಯರ್ ಮೊಮೆಂಟಮ್ ಇದೆ, right? So linear momentum here relates with, linear momentum is directly relates with velocity, right? ಸೊ ಫಾಸ್ಟ್ ಮೂವ್ ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ ಲೀನಿಯರ್ ಮೊಮೆಂಟಮ್ ಏನಿರುತ್ತೆ ಜಾಸ್ತಿ ಇರುತ್ತೆ. ಸೊ ಸ್ಲೋ ಮೂವ್ ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ ಲೀನಿಯರ್ ಮೊಮೆಂಟಮ್ ಏನಿರುತ್ತೆ ಸ್ಲೋ ಇರುತ್ತೆ. ದಟ್ ಈಸ್ ಇಟ್ ಈಸ್ ಅ ಕ್ವಾಂಟಿಟಿ ವಿಚ್ ಕನ್ಸ್ಟ್ರೈನ್ ಆರ್ ಇಟ್ ಸೇಸ್ ದ ಮೋಷನ್. ಸೊ ಎಷ್ಟು ಮೂವ್ ಆಗಬೇಕು ಅನ್ನೋದನ್ನ ಹೇಳೋ ಕ್ವಾಂಟಿಟಿನ ನಾವೇನಂತ ಕರೀತಾ ಇದೀವಿ ಮೊಮೆಂಟಮ್, ರೈಟ್. ಸೊ ಹೆವಿಯರ್ ಮಾಸ್ ಇತ್ತು ಅಂದ್ರೆ ಇಟ್ ಮೂವ್ ಫರ್ದರ್ more distance, so lesser mass ittu andre lesser distance, right. So same as it is moving with faster velocity means it has more momentum, so it is moving with lesser velocity means it has less momentum, right. So that's why we can write linear momentum is directly relates with the velocity and also linear momentum is directly relates with the mass, right. So by considering these two cases, right, so ee eradu cases na combine ಮಾಡಿ ಬರುತ್ತೆ linear momentum is relates with the mass and velocity. So mass change ಆದರೂ ಕೂಡ linear momentum ಏನಾಗ್ತಿದೆ ಚೇಂಜ್ ಆಗ್ತಿದೆ, velocity change ಆಗ್ತಿದ್ರು ಕೂಡ linear momentum ಏನಾಗುತ್ತೆ ಚೇಂಜ್ ಆಗುತ್ತೆ. So mass increase ಆದ್ರೆ linear momentum increase ಆಗುತ್ತೆ, velocity increase ಆದರೂ ಕೂಡ linear momentum ಏನಾಗುತ್ತೆ increase ಆಗುತ್ತೆ, because these two are directly related. So combining these two relations we can write linear momentum or simply momentum is directly relations with mass into velocity, right. So linear momentum is denoted by the symbol p, right. So momentum is always denoted by the symbol p, right. So p is directly relates with mass, so mass be denoted by m, either small m or capital M, right. So velocity we know v, right. So now if we remove the proportionality constant, so if we remove the proportionality, so in each and every case ನಾವು ಎಲ್ಲೇ proportionality relates ನ ಮಾಡ್ಕೊಂಡ್ರೆ ಈ proportionality remove ಮಾಡ್ತಾ ಇದೀವಿ ಅಂದ್ರೆ always that means proportional to equals we have one constant, so that constant is the proportionality constant. So ಇದು constant, ಇದನ್ನ ನಾವು ಯಾವ ಟರ್ಮ್ ಅಲ್ಲಿ ಬೇಕಿದ್ರೂ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡಬಹುದು. Constant is c ಅಂತ ನಾವು ತಗೋಬಹುದು, constant a, constant b, so any variable you can choose, right. So this we can write k is equals to m into v, right. So as here the linear momentum directly relates with only the two factors, one is mass and another one is velocity, so hence k value is equals to 1. So by this we can directly write p is equals to m into v. So one more important relation, so where p is momentum and m is mass and v is velocity. So we can define momentum is equals to the product of mass and velocity. So if they ask for define momentum means momentum is defined as the product of mass and velocity of an object. So ಯಾವುದಾದರೂ ಒಂದು particular object ಅಂತ consider ಮಾಡಿದ್ರೆ for every object it has some mass. So if this object is moving means it has some velocity, right. So from this every object has a momentum, right. So that momentum we relate mass of the object into its velocity m into v, right. So this gives what momentum, right. So if we define momentum, it is the product of mass and velocity, right. So product is multiplication of mass and velocity of any object. So each and every object has a momentum, right. So that is p is equals to m into v, right. So next, momentum is a vector quantity, it is a vector quantity, right. So vector quantity means it has both the magnitude and direction, right. So if I write vector form, momentum in vector form p arrow mark, right. So that is equals to mass is a scalar, right. So m again velocity is a vector, right. So p is equals to m into v, right. So m is a scalar and v is the velocity, right. So this is the vector form for the momentum, right. So the momentum direction is always in the direction of the velocity. So ನಮಗೆ ಯಾವ direction ಅಲ್ಲಿ velocity ಇರುತ್ತೋ so ಅದೇ direction ಅಲ್ಲಿ ನಮಗೆ ಏನಿರುತ್ತೆ momentum ಇರುತ್ತೆ, right? So the direction of momentum is in the direction of velocity. That means momentum and velocity both are parallel, right? So parallel means in the same direction. So velocity towards along x-axis ಅಲ್ಲಿ ಇದೆ ಅಂದ್ರೆ momentum ಕೂಡ same along x-axis ಅಲ್ಲಿ ಇರುತ್ತೆ. If the object is moving upward, so velocity is in the upward direction. That means the momentum is also in the upward direction, right? So if the object is moving in the negative x-axis, right, having some velocity, then momentum is also in the direction of velocity, right? So direction momentum ಯಾವಾಗಲೂ ಎಲ್ಲಿರುತ್ತೆ ಅಂದ್ರೆ it is in the direction of the velocity. Velocity ಯಾವ direction ಅಲ್ಲಿ ಇರುತ್ತೋ momentum ಕೂಡ ನಮಗೆ ಅದೇ direction ಅಲ್ಲೇ ಇರುತ್ತೆ, right? So next point is SI unit. So SI unit we define momentum is equals to product of mass into velocity. So SI unit of mass is what? Kg, right? So SI unit of velocity is meter per second. Then the SI unit of momentum is kg meter per second, right? Or we can write this one as kg meter s to the power minus 1, right? So if it goes to the numerator, it becomes s to the power of minus 1. So u kg power 1 m to the power 1. So directly we can write kg meter and s to the power minus 1, right? So this is the SI unit. So very important. So SI unit ಯಾವ್ದ್ರಲ್ಲಾದರೂ ಕೇಳಬಹುದು, right? So this is one more important relation, right? Momentum. So this is all about the momentum. So each and every body has a momentum. So momentum is defined as it is a product of mass and velocity. So it is a vector quantity. The direction of the momentum is always in the direction of the velocity. So velocity ಯಾವ direction ಅಲ್ಲಿ ಇರುತ್ತೆ, momentum ಕೂಡ ಅದೇ direction ಅಲ್ಲೇ ಇರುತ್ತೆ, right? So next SI unit, very important. SI unit is kg meter per second. So SI unit na ನಾವು ಯಾವ ತರ ಬರ್ಕೊಂತೀವಿ ಅಂದ್ರೆ that is by using the relations. So ನಾವು formula based ನಲ್ಲಿ ಅದರದ್ದು SI unit ನ derive ಮಾಡ್ಕೊಂತೀವಿ. So these are derived units. So ಇದು ನಾವು units and dimensions chapter ಅಲ್ಲಿ ಡಿಸ್ಕಸ್ ಮಾಡ್ತೀವಿ, right? So ಡೈರೆಕ್ಟ್ ಚಾಪ್ಟರ್ ಸ್ಟಾರ್ಟ್ ಮಾಡಿರೋದ್ರಿಂದ ಇಲ್ಲೇ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ತಾ ಇದೀವಿ. How we write the derived units means by using the formula. So formula ಯೂಸ್ ಮಾಡ್ಕೊಂಡು ಅದರ ಯೂನಿಟ್ಸ್ ನ ನಾವು ಡಿರೈವ್ ಮಾಡ್ಕೊಂತಾ ಇದೀವಿ, right? The unit of mass is what? Kg. That is SI unit for the mass is kg and velocity is meter per second. So these two are in multiplied. So that's why we write that one as kg meter per second, right? So this is all about the linear momentum or momentum. So formula is very important. P is equals to m into v. So linear means straight way, right? So that's why that one we call as linear momentum. So by using the linear momentum, we are going to state Newton's second law of motion, right? So the statement is the rate of change of linear momentum is directly proportional to the force applied and it is in the direction of force, right? So this is the statement of the second law of motion. That is, the rate of change of linear momentum is directly proportional to the force applied, right? So ಯಾವುದಾದ್ರೂ ಒಂದು ಆಬ್ಜೆಕ್ಟ್ ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ this object has some mass. So if we apply the force on this object, it starts to move with some velocity, right? So force apply ಮಾಡಿದ್ರೆ ಮಾತ್ರ ಇದು ಮೂವ್ ಆಗುತ್ತೆ, right? So that momentum, mass into velocity, right? So m into v is the momentum. So this momentum is directly proportional to the force. So ನಾವು ಎಷ್ಟು force apply ಮಾಡ್ತೀವೋ ಅಷ್ಟು ಮುಂದೆ ಮೂವ್ ಆಗುತ್ತೆ, right? So that one is given by the statement, that is the Newton's second law of motion, right? So ಈ statement ನ in the form of mathematical form ಅಲ್ಲಿ ಬರುತ್ತೆ rate of change. So ಇದು ಎಲ್ಲೋದ್ರೂ ನಮಗೆ ಸೇಮ್ ಇರುತ್ತೆ. Rate of change means d by dt. So this is universal. Rate of change means any change with respect to time, either it change in velocity, change in acceleration, change in force, change in momentum with respect to time. So that one we call that one as rate of change. So in the previous class we also defined velocity. Velocity is defined as rate of change of displacement. That one we call as velocity. That means here d by dt is constant. That is rate of change. So in change ಆಗ್ತಿದೆ ನಮಗೆ displacement, right? So change in displacement with respect to time we call as velocity, right? So same as acceleration, rate of change of velocity, that one we call as acceleration. That means d by dt with respect to velocity, that is change in velocity with respect to time, that one is the acceleration. So simply we call this one as rate of change of velocity, rate of change of displacement. In the same way here, rate of change of linear momentum, that means linear momentum is denoted by p, right? So dp by dt. So ಎಲ್ಲಿ ನಮಗೆ rate of change ಅಂತ ಬರುತ್ತೋ always the denominator is dt. Any change with respect to time we call that one as rate of change, right? So dp by dt is directly proportional to the force applied, right? So that is F. So ನಾವು ಏನು ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡ್ತಾ ಇದೀವೋ ಅದು ಡೈರೆಕ್ಟ್ಲಿ ರಿಲೇಟ್ಸ್ ವಿತ್ ದ ಮೊಮೆಂಟಮ್. ಸೊ ದಟ್ ಈಸ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಟೈಮ್. ಸೊ ನಾವು ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡ್ತಾ ಇದೀವಿ ಓನ್ಲಿ ಫಾರ್ 5 seconds means there is a change in momentum. So only for 5 seconds, right? So if I am applying the force for 10 seconds means there is a change in momentum for 10 seconds, right? So change in momentum with respect to time, so that is proportional to the applied force, right? So dp by dt is directly proportional to F, or we can write this one as F is directly proportional to dp by dt, right? So directly proportional. Force change ಮಾಡಿದ್ರೆ change in momentum change ಆಗುತ್ತೆ, change in momentum with respect to time change ಮಾಡಿದ್ರೆ force change ಆಗುತ್ತೆ, right? So we rearrange this one, right? This will only happens in directly relations. So directly proportional ಇದ್ರೆ ಮಾತ್ರ ನಾವು ಈ ತರ ಬರ್ಕೋಬಹುದು, right? So now again in the previous I explained, so proportionality remove ಮಾಡಬೇಕು ಅಂದ್ರೆ that is from proportionality to equals ಬರ್ತಾ ಇದೀವಿ ಅಂದ್ರೆ we need to write the constant. So that constant we call as the proportionality constant. So proportional in the equals ಬರೀತೀವಿ ಅಂದ್ರೆ always we introduce one constant, so that constant is proportionality constant, right? So F is equals to k into dp by dt, right? So from the definition, momentum p is equals to m into v, right? So substitute momentum in this equation, right? So this is very important for 5 marks, right? So statement along with this derivation. So here we have one derivation, right? So substitute p, the value of p here, calling this one as equation 1, equation 2. So substitute equation 2 in 1, or put equation 2 in equation 1. Wherever p we need to substitute that one as m into v, right? So force F, that is equals to constant k d by dt. So in place of momentum we need to substitute mass into velocity, right? M into v. So if I consider any one object, so it has some mass, right? So one car anta example tondre, car having some mass, right? So car it having some 100 200 kg, right? So the mass of the car is some 200 kg. As the car is moving, is there any change in mass? So car move ಆಗ್ತಿದೆ ಅಂದ್ರೆ ಅದ್ರ mass ಏನಾದರೂ change ಆಗುತ್ತಾ? No. So the mass remains constant, right? So ಇಲ್ಲಿ mass ಏನಾಗುತ್ತೆ? Constant ಇರುತ್ತೆ. But car will move either in increased velocity or decreased velocity. So velocity may vary, but mass will remain constant, right? So K, so mass is constant. So I will take mass as outside. So the remaining is dV divided by dt. Right? So F is equals to K into M into dV by dt. So from the first chapter, that is from the motion in a straight line, dV by dt, change in velocity with respect to change in time. That is rate of change of velocity. We call that one as acceleration. Right? F is equals to K into M into right? Because A is equals to dV by dt. So ನಮಗೆ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಸ್ಟೇಟ್ ನ್ಯೂಟನ್ ಸೆಕೆಂಡ್ ಲಾ ಆಫ್ ಮೋಷನ್ ಅಂಡ್ ಡಿರೈವ್ F is equals to ma. So ಇದು 5 ಮಾರ್ಕ್ಸ್ ಗೆ ತುಂಬಾ ಸಲ ರಿಪೀಟ್ ಆಗಿರೋದು. So and also this chapter consists of 11 marks, right? So ಇಲ್ಲಿ ನಮಗೆ ಡಿರೈವೇಶನ್ ಕೂಡ ಇರುತ್ತೆ, ಜೊತೆಗೆ ಪ್ರಾಬ್ಲಮ್ ಕೂಡ ಇರುತ್ತೆ, right? So if they ask only for the derivation for 3 marks, it is very compulsory. So 3 marks would are important. If they ask for the statement, then they will ask for 5 marks, right? So first we need to state the Newton's second law of motion, that is rate of change of momentum is directly proportional to force applied, and so force applied and it is in the direction of applied force. So now force apply ಮಾಡ್ತಿದ್ವಿ ಅಂದ್ರೆ momentum change ಆಗ್ತಿದೆ, momentum change ಆಗ್ತಿದೆ ಅಂದ್ರೆ that is also in the direction of the force. So ಅದನ್ನ ಹೇಳ್ತಾರೆ, it is in the direction of the force, right? So linear momentum ಏನಾಗ್ತಿದೆ, change ಆಗ್ತಿದೆ, so that change is in the direction of the applied force, right? So in the mathematical form we will write dp by dt, that is equals to applied force, right? So now we can interchange or we can directly write dp by dt is equals to f k into f. So there also k is a constant, right? So now substituting p, that is equals to mv from the definition of the linear momentum, right? So momentum is equals to mass into velocity. So the mass of the object will not change while its motion. So now ಯಾವುದಾದರೂ object ತಗೋಬಹುದು, ಮೂವಿಂಗ್ ಅಲ್ಲಿ ಇದ್ದರೆ ಅದರ ಮಾಸ್ ಏನಾಗೋದಿಲ್ಲ, ಚೇಂಜ್ ಆಗೋದಿಲ್ಲ, ರೈಟ್? ಸೊ ಚೇಂಜ್ ಆಗದಲ್ಲ ಇದ್ದಾಗ mass is a constant. So keeping outside, only we are differentiating with respect to velocity, dv by dt, right? So dv by dt is what? Acceleration, right? So F is equals to K into ma, right? So if K is equals to 1, then we get the final relation F is equals to m into a, right? So very important relation. After the momentum, the second most important relation is force, that is equals to mass into acceleration, right? Again, force is a vector quantity. So if I write in the vector form, mass is a scalar, so keeping as this, F is equals to m a. So the direction of the applied force is in the direction of the acceleration. So now force apply ಮಾಡ್ತಿದೀವಿ ಅಂದ್ರೆ change, momentum change ಆಗ್ತಿದೆ. Momentum change means velocity is changing. As velocity changes, there is an acceleration, right? So acceleration is also in the direction of the applied force, right? So momentum, acceleration, velocity both are in the same direction, right? So here also force, applied force is in the direction of changing velocity, or acceleration is in the direction of the force. So now we all ಬೇಕಾದನ್ನು ಹೇಳ್ಬೋದು, right? So next, SI unit. So SI unit of force. So again, by using formula we are going to give the SI unit, right? So force F is equals to ma. So mass SI unit should be small letters, right? So or so Newton na symbolic representation ಮಾಡಬೇಕಾದ್ರೆ we should write that in capital letter. So capital letter ಅಲ್ಲಿ n ಅಂತ represent ಮಾಡಿದ್ರೆ it gives what? The unit of force. So Newton is the unit of force. So word ಅಲ್ಲಿ ಬರುತ್ತೆ small letter ಅಲ್ಲಿ ಬರಿಬೇಕು, laterally mention ಮಾಡಿದ್ರೆ it should be in the capitals, right? So 1 newton is equals to 1 kg meter per second square, right? So if we define the newton, right? So newton define ಮಾಡಬೇಕು ಅಂದ್ರೆ 1 newton by using the same formula, that is F is equals to m into a, right? The force which is applied on any object which having the mass 1 kg. So ಯಾವುದಾದ್ರೂ ಒಂದು ಆಬ್ಜೆಕ್ಟ್ ಅಲ್ಲಿ ಮಾಸ್ 1 kg ಇರಬೇಕು, the applied force 1 newton ಆಗಬೇಕು ಅಂದ್ರೆ it should be accelerating with an acceleration 1 meter per second square, right? So ಇಲ್ಲಿ 1 newton ಆಗಬೇಕು, f ಅಂದ್ರೆ ಮಾಸ್ ಎಷ್ಟು ಇರಬೇಕು 1 ಇರಬೇಕು, acceleration ಎಷ್ಟು ಇರಬೇಕು 1 ಇರಬೇಕು. So 1 into 1, finally we get 1 newton, right? So f is equals to ma, that is 1 kg of an object into its moving with an acceleration 1 meter per second square, then we get the force is equals to 1 kg meter per second square, right? So that means we are applying the force 1 newton. So ನಮಗೆ 1 newton ಬೇಕಂದ್ರೆ object should be mass ಎಷ್ಟು ಇರಬೇಕು 1 kg ಇರಬೇಕು, it should be accelerating with 1 meter per second square, right? So that use what the newton, right? So if so this is for only one dimension, so linear momentum, linear force, linear acceleration, so all these are in one dimension. If the object is moving in a space, right, space or two dimension. So ನಮಗೆ ಎಕ್ಸಾಮ್ ಅಂತ ಹೇಳಿದ್ರೆ up to here is the last. So in case if they ask for one, write the vector form for the Newton second law means we need to write F is equals to m into a, that is should be the vectors, right? So ಇದು general SI unit 1 marks ಗೆ SI unit ಕೇಳಬಹುದು, right? So if the object is moving in space, that is in 2 dimension or it is in 3 dimension, so the position of the force we can write F is equals to Fx I cap plus Fy j cap plus Fz k cap, right? So that means Fx is the force which is acting along x axis, Fy is the force which is acting along y axis, Fz is the force which is acting along z axis. And again acceleration is also a vector, right? So idu three dimensional ಹೋಗ್ತಿದೆ ಅಂದ್ರೆ it has been the acceleration in all the three directions, right? So ax I cap plus ay j cap plus az k cap, right? So we have the formula F is equals to m into a, right? So for the force we can write Fx I cap plus Fy j cap plus Fz k cap, that is equals to mass is a scalar keeping as is, so substitute for a ax I cap ay j cap plus az k cap, right? So any vector we can multiply with the scalar, right? So m into ax I cap plus m into ay j cap plus m into az k cap, right? So in the LHS we have Fx I cap plus Fy j cap plus Fz k cap. So comparing these two, so LHS is equals to the RHS. So I cap is the unit vector which is along the x-axis. So its magnitude is max, and here its magnitude is Fx. Right. So comparing these two, we can write Fx that is equals to max. Right. So similarly, Fy that is equals to may. Fz that is equals to az, right? So these are the magnitudes of the force which is acting along x-axis, y-axis and z-axis. So this is in space or 3-dimension motion or in rectangular components. So ಯಾವುದರಲ್ಲಿ ಬೇಕಾದರೂ ನಾವು ಇದನ್ನ ಹೇಳ್ಬೋದು, ರೈಟ್? So these are the magnitudes. Fx is equals to max, Fy is equals to may, Fz is equals to maz, right? So this is in the vector form in 3 dimensions. So this is only in 1 dimension. So if they ask only for 1 dimension, so F is equals to Fx I cap, right? So A is equals to Ax I cap, right? So the magnitude of the force is Fx, right? So there is no need to mention the direction, right? So F is equals to directly m into Ax I cap, right? So F is equals to max. So we get directly ma, right? So if they given along x-axis, Ax along x-axis, Ay along y-axis, Az along z-axis. So this is in the vector form, right? So next, so we have the relation force is equals to m into a, right? So where m is the mass of the object, when we apply the force on the object, right? So ಯಾವುದಾದರೂ ಒಂದು ಆಬ್ಜೆಕ್ಟ್ ಗೆ ನಾವು push ಅಥವಾ pull, so ಎರಡನ್ನೂ ನಾವು ಏನಂತ ಕರಿತೀವಿ, force ಅಂತಾನೆ ಕರೆಯೋದು, right? So if we apply the force on the object will starts to move in the direction of the applied force, right? So ಯಾವ direction ಅಲ್ಲಿ force apply ಮಾಡಿರ್ತೀವೋ ಅದೇ direction ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, it starts to move. So it starts to move means there is a change in velocity, so we are getting the acceleration. So that is the relation F is equals to ma. So force apply ಮಾಡಿದ್ವಿ ಅಂದ್ರೆ mass ಇರುತ್ತೆ, again we are getting the acceleration, right? So now when acceleration is equals to 0, so now force apply ಮಾಡಿದಾಗ ಇಲ್ಲಿ ನಮಗೆ ಬರ್ತಿರೋ acceleration ಏನಾಗುತ್ತೆ 0. So in case ಅಲ್ಲಿ acceleration 0 ಆಗಿತ್ತು ಅಂದ್ರೆ that means the velocity from the first chapter, that is we have the relation v is equals to u plus at, right? So when acceleration is 0, right? So here substituting a is equals to 0, we get v is equals to u, right? So acceleration 0 agide andre 0 into t is 0, so v is equals to u when a is equals to 0. That means when acceleration of the object is 0, right? So that means the object is moving with constant velocity, right? So object ಏನಾಗ್ತಾ ಇದೆ, moving with a constant velocity. So now substitute same a is equals to 0 in the relation F is equals to ma, right? So a is equals to 0, so 0 into mass, we get again force is equals to 0, right? So when a is equals to 0, we getting force is equals to 0. So in this case acceleration is 0 from the from the equations of motion, we are getting v is equals to u. That means the object is moving with a constant velocity and the force applied on the object is 0. So it states means from the second law we can define the first law, Newton's first law of motion, right? So Newton's first law of motion adantane heludu, when the object is moving with a constant velocity, then there is no net force acting on the object, right? So object moving with constant velocity idaga adruddu net force enagirutte namage 0 ಆಗಿರುತ್ತೆ, right? So ಇದನ್ನ ನಾವು Newton's first law dalli statement ಆಗಿ define ಮಾಡ್ಕೊಂಡಿರೋದು. So from the Newton's second law of the motion, we can define the first law of motion. When the acceleration of the body is 0, then the net force acting on that object is 0. The object is moving in an uniform velocity, right? So conversely, if the applied force is equals to 0, right? So force apply ಮಾಡ್ತಾ ಇದೀವಿ object ಮೇಲೆ 0 ಅಂದ್ರೆ ಯಾವುದೇ ತರದ force ಏನು ಮಾಡ್ತಾ ಇಲ್ಲ, apply ಮಾಡ್ತಾ ಇಲ್ಲ object ಮೇಲೆ. That means if there is no force, we have the relation F is equals to ma. So force 0 ಆಯ್ತು ಅಂದ್ರೆ mass 0 ಆಗೋದಿಲ್ಲ, because mass has a value. So m is not equals to 0, then a is equals to 0, right? So when force is 0, acceleration of the object is 0. So acceleration 0 ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ object ಏನು ಹೇಳ್ತಿದೆ ನಮಗೆ, object is at rest, right? So ಎರಡು ಕಾನ್ವರ್ಸ್ಲಿ ಇದನ್ನ ನಾವು ಫಸ್ಟ್ ಲಾ ಆಫ್ ಮೋಷನ್ ಅಲ್ಲಿ ಸ್ಟೇಟ್ ಮಾಡಿದ್ವಿ, ರೈಟ್? ಸೊ ವೆನ್ ದ ನೆಟ್ ಫೋರ್ಸ್ ಆಕ್ಟಿಂಗ್ ಆನ್ ದ ಆಬ್ಜೆಕ್ಟ್ ಐದರ್ ಇಟ್ ಮೇ ಬಿ tends to be in the state of rest or it may be moving with a uniform motion, right? So aduna ನಾವು ಫಸ್ಟ್ ಲಾ ಆಫ್ ಮೋಷನ್ ಅಲ್ಲಿ ಸ್ಟೇಟ್ಮೆಂಟ್ ಅಲ್ಲಿ ಇರೋದನ್ನ, ಸೊ ಫ್ರಮ್ ದ ಸೆಕೆಂಡ್ ಲಾ we can conclude the first law of the motion, right? So object moving ಅಲ್ಲಿ ಇತ್ತು ಅಂದ್ರೆ ನಮಗೆ ಫೋರ್ಸ್ ಏನಿರುತ್ತೆ 0, that means net force is 0. ಸೊ ರೆಸ್ಟ್ ಅಲ್ಲಿ ಇದ್ದವರು ಕೂಡ ಏನಿರುತ್ತೆ ನಮಗೆ ನೆಟ್ ಫೋರ್ಸ್ 0. ಸೊ ಯಾವುದೋ ಒಂದು ಆಬ್ಜೆಕ್ಟ್ ಇದೆ ಅಥವಾ ಈ ಬೋರ್ಡ್ ಇದೆ, ರೈಟ್? ಸೊ ಈ ಬೋರ್ಡ್ ಗೆ ನಾವು ಯಾವುದೇ ಒಂದು ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡಿಲ್ಲ ಅಂದ್ರೆ ಬೋರ್ಡ್ ಏನಾಗುತ್ತೆ? ಮೂವ್ ಆಗೋದಿಲ್ಲ. ಸೊ ಮೂವ್ ಆಗೋದಿಲ್ಲ ಅಂದ್ರೆ ಆಕ್ಸಲರೇಷನ್ ಏನಿರುತ್ತೆ ನಮಗೆ 0. ದಟ್ ಮೀನ್ಸ್ ದ ಆಬ್ಜೆಕ್ಟ್ ಇಸ್ ಅಟ್ ರೆಸ್ಟ್, ರೈಟ್? ಸೊ ದಿಸ್ ಇಸ್ ದ ಸೆಕೆಂಡ್ ಲಾ on first law of motion, right? So second law na universal law anta kuda kariತೀವಿ because we can define the Newton's first law by using the second law, and also we can define Newton's third law by using the second law, right? So hence Newton's second law of motion we call as universal law of motion, right? So by using this relation we can define first law of motion and also the third law of motion, right? So here is the example for the first law of motion, right? So when a is equals to 0, f becomes 0. So when f is equals to 0, a becomes 0. So either the object is at rest or it is moving with a constant velocity. That means uniform motion. So object is moving in a uniform motion, right? So few more concepts related to the second law of motion we will discuss in our next class. Thank you. Doubts?